Hey everybody, and welcome to this video where I'll be continuing to talk about n8n using Llama and introducing some other concepts like memory and tools and workflows. So last time when we left off, we had an AI that could give us answers in the style of Homer Simpson, basic chat answers. And if you don't know how to create that basic chatbot template that I've got here, just go back to the first video and you'll see the explanation of the setup. So I'm still using the same system. I'm not using a backend. I'm just using local front-end data, just really to have the basis of how we can test our system and then build upon it later once we've got it configured the right way. And so today the idea is that this is a chatbot with a bit of a funny job. So the job of this chatbot is when I ask a question to it, or when I converse with it, its job is to interact with a database to either create or read data in the database. The database that I'm talking about is a Pocketbase database. So I've set up a Pocketbase locally, and I've set up one collection called Cats. And in each of these collections, there's a name, a breed, and an age, just for a really simple example. So this isn't obviously a practical example, but I just wanted to see how efficient the AI would be in terms of running a workflow, passing data to that workflow that enables it to actually read and write from a database. Because that for me is really exciting. Just the concept of, instead of having the user input the data in a form, what if the user could converse their way through the form? You know, typical questions of what am I supposed to put in here, and what type of input are you expecting from me in this field, and people making mistakes and getting things wrong. If you give the same data to an AI, then in theory, no matter what the user says, it's going to mutate what they've said into the correct format and then put that in the database in the right way. So even if they make a mistake and they make a spelling mistake in European for a breed, for example, then the AI in theory is going to correct that before putting it into the database. So it's just a concept, and it's also a way to show how the workflow calls work in n8n, and a little bit of an extra chatbot step. So let's just see how well it works. First of all, take a look through how it works, and then see how well it works, and talk about some pros and cons, some strengths and weaknesses, and also comparing Llama with ChatGPT as a tool to make this work. So starting, we don't really need to look through the app. As I said, you've already got that from last time. We'll be having a conversation to test the efficacy of this workflow in a minute. The way it works is we've got first port of call is a chatbot, as we had before, but this time there's a very specific system message, which is it has a task to read and write records from a database tool with the n8n tool called read write database. I've been really specific here because I find, and this is the first weakness that I think needs fixing, and then n8n are working on it. I think they're producing updates as we speak, because there was one 4 days ago for this exact node to make it call the tools more efficiently. But at the moment I'm trying to be specific, because if it doesn't think that it has the right input to be able to mutate it into what the tool is expecting, then it won't run, and it'll just throw an error saying this is not the right input format. So I've tried to make it as specific as possible to get around that. It works like 4 times out of 5, I would say, with Llama 3.2, the 3 billion model, I think. So we have to read write in when calling the tool. This is something I found on a GitHub issue conversation. It was that the input must always be input, or else it will throw that error saying that the tool didn't get the right input. The user will ask questions about cats. You must translate that into either a read write request. You must provide responses based on results. If the user specifies an age for breed, fill in the appropriate fields. If no specific values are given, leave the field empty and set action to read. If the user asks to create a cat, the action must be set to write. I think the more information you can give, the better, without confusing the tool. It seems to work. From a lot of testing I've done over the last day, that seems to be the best way to do it, to give it a medium amount of very detailed and concise information, certainly at the system message step. I've asked it to return intermediate steps because it helps to debug. The difficulty with debugging this is you can't really see in between when the request is received by the agent and when it actually produces a response. You can't see where it went wrong in terms of what it understood and how it formulated the input for the tool. So it's a good way to do it. We're still using the Llama chat model. I've experimented a bit with temperatures and top K and stuff based on ChatGPT information, trying to reduce the temperature and things, modifying values to make it more specific and less conversational. But I didn't really like it, and I think it didn't really make that much of a difference, so I preferred to keep it at defaults. I think probably the defaults that are set by n8n are pretty good. The reason to use ZEP instead of system memory, I couldn't find a way. If we look at that memory, what one I'm talking about, memory. So the window memory buffer, I couldn't find a way to clear it in testing. So when I was testing it with chat, I couldn't clear the window memory buffer, and it kept coming up with answers that were based on previous conversations. Like with the app, I'm attaching a session ID, a unique ID to every chat session. So then it clears the memory automatically between sessions. But from what I read, the window buffer memory is just really for testing. And once you get into something where you want it to really work, then try something else. And so my choice was ZEP, which I tried to install locally, and it was pretty complicated to get it to work. There's not a huge amount. There's some documentation, but it's not fully developed, I don't think, or it's not developed enough for somebody like me who's not a professional coder to work with. So I used the cloud version of ZEP with an API key. And the cool thing about ZEP is it's saving the sessions, but it's also saving the what it considers as facts about the session. So it'll interpret with its own system the conversations that have happened. It'll keep the messages, it'll keep a summary, and also it'll keep facts. And so then it uses this in future sessions for the same user. If you have a user specified, a user ID specified, it'll use this data in the future as like it'll search through what it has to see, do I have any information that relates to the request? And I'll return that information to the AI. So what you're avoiding is something with a context window that's quite short, like Llama 3.2. You, instead of having to access the entire conversation history for that user to see what information we can gather, ZEP is automatically going to just return the relevant bits and pieces. So it'll be a much, much smaller number of tokens in the context that the AI is receiving, which will help with the precision of responses, but also help the user to feel like the system knows them a bit better because it can remember things that they've said before. And I think this is a big deal at the moment with GPT. I've just introduced at the time of making the video, it was a few weeks ago, they introduced memory. So it was started creating memories every time you had a conversation if it found that there was an important fact that it needs to save about you, and that goes into the context of future conversations. So cool tool. I haven't really explored it all yet, but certainly for the memory, it's working well for the time being. And then there's this tool, read-write database. So read-write database is a tool that we call to perform any task related to querying or modifying the cats database class. The tool is the only one you should use for retrieving or adding cat records. Use the following format. Now this is already specified below, so I might not actually need that. Maybe I'll just delete it, see if that helps. If the user asks to find a specific cat, fill in the respective fields. That's in the input schema. Where was it? Fill in the respective fields of the input schema and set action to read. If the user asks to retrieve all cats, leave fields blank and set action to read. If the user asks to add a cat, then set action to write. Use this tool for all cat related requests, including queries like which cat is X years old, show me all cats, find a specific cat. Because I was having problems with it interpreting this before. If you didn't say, please use the tool to query the database, it wouldn't understand. But this way it can infer, okay, I can see from the instructions that show me all cats or something similar means that I should do a blank query of the database. And again, this thing of when the tool is called, the input must be input. So to make sure that it's being communicating correctly between the tools agent and the workflow. So the workflow is this. We can add one of these per workflow. So you're able to if you just want one task for this tool to do, you can just add it directly in here. Otherwise, create a separate workflow and as many as you want. And then you can have the tool call the workflow by the ID. So at the moment, I'm calling it by current workflow ID. So this is a metadata variable for n8n. It shows the current workflow's ID. But I could also specify a specific ID or call from list. You can call a specific workflow from the list of your workflows. So if you create a whole bunch of them, like one for read, one for write, one for update, one for delete, then you would have multiple tools attached, multiple n8n workflow tools attached, and you would just use, here's the one from the list that I want to use, and then it'll call that one when it needs it based on the description and the name. So at the moment, I'm just doing this one for testing so I can do it in the same screen, in the same canvas. So it's going to receive the information from the AI. The AI will actually send over this kind of, it uses this JSON example to send the request. And then it'll get a Pocketbase token. So it'll use the admin details, which are here. It's local, so I don't care. It calls the auth with password from the admin's API to get a token that will allow it to use the token. So I add the original request with the token. And then it goes through an if statement that checks if it's a read or write action that the AI has sent over. It encodes search parameters because the search parameters in Pocketbase are a bit funky. They have to be put into the URL. So it has to be like collections, cats, records, question mark, filter equals, and then like name equals whatever. And it doesn't seem to play very nicely with null values or undefined values. So I had a lot of trouble getting it to do like a blank database search, because if it puts in like name equals empty string or name equals null, it still was returning nothing. It was looking for something where the name was empty and it didn't find it. So the best solution was just to encode, and you have to have them encoded as well. It doesn't work unless certainly the stuff that's inside the filter is encoded, URL encoded. And the main problem with that was that the solution to the problem was that this will push, depending on what values have been supplied by the AI, then it'll push the right filters to the URL. So this is probably a very hacky solution. I'm sure there's a better way to do this. And if you were using this as like a full system, not just for one table, then there would be a lot more, I think, to do here. This is just for this one specific example. So anyway, it encodes it passes it on to the query, which takes the URL of the query and the token from the other step where we got the token. Or it writes a cat to the database, and so this one is easier because it's a post request and it uses body parameters to the API endpoint cats records, and so it posts the name, the breed, the age, if there is one. Otherwise it just posts an empty string. Then this was something I saw from some of the n8n examples where they get it to kind of mutate the response a bit nicer for the AI to understand. So this just takes the basic JSON from the response from Pocketbase, which is just a successful creation of the record. And this one, it takes the items from the input, or the JSON. It doesn't output like a stringified JSON, which the AI had difficulty understanding. It actually outputs a list, an array of items, and returns that as JSON to the AI. So when the AI gets that back, then it formulates an answer and returns the answer to the webhook, so to our front end in Noodle. Now, if it doesn't, the problem is it just crashes and doesn't return anything. So you need to go into the settings and say when it's erroring, you want to use the error output. So when the error output happens, what I did was took another tools agent with no tool. So why not a conversation agent? Because the conversation agent seems to have really complex instructions, and it has a hard time just understanding a simple request in a chain of requests. So the tools agent does a better job of just answering really simply without a whole bunch of n8n predefined agent and human instructions. So this one is just designed to take an input error code and explain it in your output to the user. So this could be probably better developed, but at the moment it works fine. So it gives the error JSON from the error from the JSON from the previous step, and then it'll take that and translate it into something the user can understand and then output that. So it means no matter what happens, even if there's an error, which there often will be, it'll still output something. And it doesn't always make sense, but within the first one or two in Llama 3.2, it does make sense, and then it starts to fall off and not make so much sense. So that's the n8n tool. I think I've presented all the different bits of it. Let's take a look and see how it works to actually create something in our database. So let's say, please create a new cat. So I do specifically try to not specify exactly what it's supposed to do. I'm putting myself in the user's shoes. And in fact, let's say something like, please add my cat to this app. His name is Fergus. He's a European cat and he's 4 years old. Now, we'll see what happens with the chat. We'll see what happens in n8n. We'll see what happens in Pocketbase. There's a lot of different areas to explore. So it's ran, it's done something. It has, so it has run the workflow. What it does is it runs so the tool receives the request, runs the workflow. So you get an output of an execution for that workflow, and you can go through and see how that's worked out. And you can also see the workings of the chatbot. So this is really important to understand that one execution is the chatbot doing its job while it calls another workflow, which would be the case if, for example, it was calling a workflow that you have somewhere else. You would have to go and look at the logs from both workflows to understand what's happened. Just because I have them in the same place, they're running as two separate executions in the same workflow. So let's have a look at what it's done. Has it created Fergus, European 4, and it says cat added successfully. Fergus, the European cat who is 4 years old, has been added to the cats collection. So it does produce a conversational response, which I find really nice to what it's done. Now let's try in the same conversation, which I'm going to be shooting myself in the foot on purpose to show you the weaknesses of these models and this system. We're going to, in the same conversation, say, okay, find me another cat. Do we have any other 4-year-olds? Yes. Find me another cat that's also 4 years old, like my one. Now, if it errors out, it's gonna take a bit longer because the one of the weaknesses of this tool is if it errors out, it's going to take a little bit of time to do the tools agent and then error, and then it's going to take a little bit of time again to do the response to the user, and then I think that's what's happened because it looks like it's crapped out. Yeah, so it has crapped out. So it's given, I bet, 100 euros. Yeah, it's given this error. Received tool input did not match expected schema. So this is, I've seen this a lot, and it seems to simply be an error of or there's a way to see what it is. Where is it? Not there. Nope. Okay. It seems to be something that could be a bug. It's just a way that this agent is finding difficulty communicating with the tool. Now, when I use OpenAI instead of Llama 3.2, it does increase the probability of a successful response. So I do think it's also the capacity in terms of intelligence of the model to be able to mutate the response in the right way. So it might just be an issue with Llama, possibly. Show me all the cats in the database. Now, please. Now, there's another thing, like I mentioned earlier, it could just be that the memory and context window length is the problem, and that since I'm asking a second question, it has more difficulty responding correctly because it has more data than it had before, and so it starts to forget a little bit the instructions. And now it's just hallucinating, I think. If you'd like to, no, sorry, there's already a cat named Fergus. So this is, again, this is an issue I'm having. So if someone knows a solution to it, I would love to hear about it because I've looked it up and I can't find it. It seems like when I ask follow-up questions, it kind of defaults to understanding the first question, or it's taking the entire context and it's looking at Fergus and not really focusing on this as the most pertinent information that it needs to work with, like that it seems to be just working with everything all at once. So this is an issue. And why I know this is an issue is because if I take this and copy paste it into a new conversation with a new session, so I'll just say find me a cat that's 4 years old, like my one, it should be able to interpret through that. Because this is the first question in a new session with no memory, I feel like, and again, I'm assuming because there's not that much debugging going on, not much logging going on in n8n in terms of how the model translates the data. I know, needs more information. So this again is saying it's received tool input did not match the schema. So at least it tells me on this side what the problem is, which is better than nothing. But let's do show me all the cats, please. We can see each time, because if it runs and then another execution runs like that one, then we know that it's running the query. So we know that it successfully matched the chat input with the tool request. And there we go, all the cats in the database. Now, if I asked it to do something related to the data that it's just got back, it sometimes is not able to do it. So I'll say, which of the cats is older than 5? It might not be able to handle sometimes calling the tool and sometimes not. Probably because my instructions are so strict, saying you have to call the tool for any kind of cat related request. So it might be partly my fault as well for not writing the instructions well enough. Again, if you have suggestions, please let me know. Again, look, it says human, show me all the cats, AI. So it's kind of copy pasting the response literally from like the conversation from before. And then it says, I requested to show all cats. There's a mismatch to provide more accurate. So it ignores this question until the very end. I can tell you which of the cats is older than 5. So it's kind of like it's mashed up this question with all the other stuff and it's lost the context. So this is me just working with it and trying it out. But certainly the query works. I can also do a specific query. Find me a cat that is 4 years old, please. In theory, that should work if I just say, find me a cat, and it should match it to the tool. But again, like 4 out of 5 times it works, 1 out of 5. The first one just won't work. There we go. I found a cat that's 4 years old named Fred, who's of Japanese breed. And Fred is 4 and is Japanese. So just found the first result out of 2 and returned that first result. So that works. So one shot, it works. 2 or more shots, more difficult. Again, is that because of Llama? I don't know, but let's compare just quickly and have a look. I think I can do this pretty quick. We'll leave Llama as the error helper and we'll set OpenAI. Now, this is another thing that I've seen that I want to tell you about. I'm going to select 4o-mini just to make sure that we're not using the most powerful model, but we're still, like, it's cheaper, but it's still a good model. It still should be able to do the things that we need. I don't need to mess around with any of this stuff. Let's just leave it like that. Now, another thing that's important is, one of the pieces of advice I've seen is using a model like Llama for your first tools agent and then having it fall back. So if there's an error, have it run a second tools agent that's actually running OpenAI with a much stronger model, and pass the same information to that one and have it do the same tool. So the same read-write database, just copy paste it, have it do the same one, and then maybe have it lead to an error bot. If everything goes wrong and there's really no way, then have an error bot in there. So you could have 3 bots in that lang chain way, 3 bots chained up that are all, that the user doesn't see. It just, they see the loading spinner and then they get a response. It means that if the first one with Llama craps out, the second one with ChatGPT might be able to, with GPT-4 or whatever, might be able to pick up the slack and answer the question. And if not, then it just delivers an error. So that was, they called that a fallback agent. So it might be a good idea if you're using Llama. I mean, what that means to have a fallback agent, what that means is that you will say 4 out of 5 times it works. That means that instead of paying OpenAI for 5 requests, you're only paying them for 1. And you've got 4 that are running on your own server running Llama 3.2. So I think it's a great idea for not using a sledgehammer to break open a nut. Most of the time, Llama is fine. And then sometimes for a more badly worded request or something with spelling mistakes or whatever, then maybe you need OpenAI to do that. Anyway, let's see if it works better this time. So we're going to do the same request as before. We're going to say, please write a cat to, please add my cat. Her name is Snuggles. She's 3 and she's Persian. I'm not sure Persian cats are very snuggly. Maybe they are. So there you go. That was fast and successful. We'll double check. No, completely unsuccessful. Fast and crap. Thank you, OpenAI. Let's have a look at what happened there. I imagine OpenAI passed the wrong query data. Yeah, empty object. And so what did it pass in the tool? It did pass in, no, that's the response, excuse me. That's the response. So it's doing input, action, write, name, snuggles, breed. So it did actually do the right input. Invoking rewrite database with input, action. Yeah, it seems to be okay. Why did that not work? Well, anyway, it didn't work. So whatever happened, it didn't quite come out the way it was supposed to. Breed, none, yeah, because it's passed through stuff that's, yeah, look, input, action, write, name, snuggles, breed, Persian. It should have worked, that it didn't. So that's something to think about. After my great example of ChatGPT, show me all the cats. Come on, don't make me look stupid. I chose you for a reason. So it's giving me all the cats in the database. Which of them is older than 5? Oops. So I made a mistake. Hopefully ChatGPT will be able to figure that out. There are no cats older than 5 in the database. And I know why it's done this, by the way. It's not wrong. It's that the way that I've set up the query is not good. That what it's done is it's sent through a read request for anything of age 5, not age greater than 5, because my parameters are fixed to equals and not to maybe greater than, maybe less than. So I could have also had a schema. The solution to that would be to make the schema more complex, and to say that when I have age 2, it's actually an object where it could be like the value, like let's say the label is age, the value is 2, the operator is greater than. And then I can, the chat will pass that through, the agent will pass that through to the workflow. And then in the workflow encoding search parameters, I can say that it pushes not equals, but whatever the operator is to the filter condition, for example. So it could be one way around that. So it's not wrong, it's just search for the wrong thing. So let's say, find me a cat that's 4 years old. Now, will it work as a chain of things in a conversation or not? And it did. So you can see that power-wise, we can say, please create a new cat that has the same info as Fergus. Chain-wise, it's working better. It's able to manage more context, potentially. Here are the details. Okay, so that again didn't work. It's tried to create a cat, and for whatever reason, it's not passing through the right data to the creation workflow. So that's something to debug. But you can see how, compared with the Llama, which was able to do about one shot, and afterwards we get confused, GPT with this greater context window is able to keep the conversation going for longer and actually understand repeated requests and not mix up all the old data. So I feel like there's something maybe I'm doing wrong with Llama, or I'm just pushing Llama too far for something that's running on 2 gigabytes of RAM compared to GPT 4o-mini, which is, I imagine running on a bit more RAM with like the billions of parameters that it has. I imagine that's part of it. But yeah, I wanted to show the comparison with OpenAI to at least show that, yeah, if you want to use Llama, you've got to try to work within its limitations, and maybe this kind of thing is a little bit too complex for something like Llama. But a pretty cool use case, I think, in terms of how we can use this AI and this LangChain concept with n8n workflows to actually produce quite complex results, passing data from the AI through a workflow, doing whatever the heck you want with it, and then the response going back to the AI to be mutated into a conversational response. So I'm pretty happy with this. I was really excited to do this experiment. I'm really glad that it worked out. I've loved using Pocketbase as usual with its fantastic API documentation. I could have probably installed the Pocketbase SDK for JavaScript into the n8n environment in Docker, I imagine somehow, and then used some nicer methods of requests and being able to initialize Pocketbase a bit more easily from in n8n rather than doing HTTP requests, but it doesn't really make that much of a difference. So it's been great using the API documentation from Pocketbase, and the interface is fantastic, and I'm really looking forward to more updates from Pocketbase. It's at the moment probably one of my favorite go-to easy peasy backends. If you don't know about Pocketbase, I've got another video on it in my channel, so go and check that out. So yeah, I hope you enjoyed this. I hope that's given you some inspiration on how you could create a more complex chatbot with n8n, and I look forward to seeing you in the next video.